Okay, you ready? All right, so what do you know so far about Newton's method? Mm-hmm. Mm-hmm. It'll find so like when it's like when it's like solve this equation, right? Let's say this answer is we don't even know what it is, but let's say it's 2, right? And this is also 2, right? To make it true. Well, even if you moved it over here and set it to 0, that 2 never changed, right? The only difference is though is that now you've created a brand new equation, and this is like kind of like your y. You set your y equal to 0. So now when you solve for x in your new universe, your x happens to be the y-intercepts. But in the old universe, your x was actually like a point of intersection. Like you had some sort of like parabola or like some sort of you had some sort of cosine graph, and you had a linear equation, and like you have these intercepts right here, these intersections. Let's say this is like -3, and let's say this is like 2, like as far as x is concerned. You see that? Well, then over here, um, on this universe, this is still -3, and this is still 2, except it's with one graph, not two that are intersecting. So that point of intersection has just become the x-intercept because you set it equal to 0. Yeah, yes, it's like a different universe that kind of ties back to the original. Yeah, just move all the stuff so you have 0 on one side. But it helps to understand what you're doing, like why you did that. Okay. Yeah, I think you get it. Okay. No, to guess the roots. We're guessing the roots. We're cave people. So we have we're putting in a 0, and we found that y is positive. I guessed it. It was a pretty number. I know that cosine. I know cosine becomes. I know that this whole thing. In fact, I know this whole thing becomes 1. That's kind of a cool. That's a convenient number, right? Easy values, right? So the numbers with cosine that I would pick would kind of be like that one, or that one, or that one, or that one. Okay, so the other cosine value, but now that I did pi, by the way, and we got pi to be negative, so we know that there's a root, because with one cosine value we got this entire thing to be positive, right? And then we did it again, and we got the entire thing to be negative, right? So we know that it's the y values are switching signs. But, huh? So we know that y. So here, like right here, so this, you could think of this as all being y on your new universe. See, that's all y, and we set y equal to 0. Okay. So so we know that since y went from positive to negative, we have a root. It's crossing the x-axis. Correct. But Newton's method requires like these iterations. It's like try this number, then try this number, then try this number, then try this number, then try this number. But because you know how to use a calculator, it's not going to be awful. So change signs. When we plugged in, we picked clever numbers that made y change signs. Yes, to get from because the y changed signs, right? Okay. Also because it's a continuous function. Okay, so but I don't like 3. I mean, we got pi. I mean, that's cool and all, but all we've established is that we know that root, we know that this value right here, right, is somewhere between 0 and 3. It'd be way cooler if we knew it was between 0 and 1, or between 0 and 2, because 0 and 3 is kind of far away. So we're gonna try 2. Let's see if it's still negative when we do 2, right? So 2 radians, not degrees, just because it was also in pi radians. So then you do 3. Do it up here. You have so 3 cosine. So 3 cosine 2 minus 2 minus 1, right? Negative. Did you get negative? 3 cosine 2 minus 2. It's okay. Negative. Yeah, so now I know, actually, I could do a better one. I know that it happened between 0 and 2. I know that it went from 0 to 2. I'll put my 2 over here. Then it goes like this. But why stop there? Let's try 1. So let's try 1. Okay, so we're going to do 3 cosine 1 minus 1, right? Minus 1. Because isn't it 3 cosine x minus x? Yeah. Okay, so let's try 1. 3 cosine 1 minus 1. So 3 cosine 1 minus 1. 3 cosine 1 minus 1 minus 1. Negative. Cool. And that makes our work a little easier now. So now we know that, all right, I know it's between 0 and 1. That's good enough. So we know it's between 0 and 1, and it crosses like that. Okay, hold on a sec. Thing. Okay, so we're going to pick a number between 0 and 1. So we're going to say 0.5. Okay? So we're going to get, let's put down our equation again, which is up here. Yeah, and we're also going to write it like this. So we're going to write it like f of x equals that, which we're saying equals 1, which we're saying, well, we're going to let y equal 1. But this is our function. Like this is our, I mean 0, c equals 0. Right? We did that when we moved it over. But our core function, the new universe function, is this one right there. Okay. So the first thing we're going to do is we're going to say x1. We're going to make x1. Actually, if I would do this again, I would do this f of x. And I'll put my x in here, like that. Okay. So we're going to say x1 equals 0.5 because 0.5 is halfway between 0 and 1. Okay. Then we're going to go ahead and do we do our derivative? We haven't done our derivative yet. So we're going to say over here, f of x, just the OG, f of x equals 3x squared, 3 cosine x, 3 cosine x minus 1. Okay, then we're going to take the derivative of that. We're going to say f prime of x equals, what? Okay, then we're going to use Newton's formula, which actually is really easy. So here, it's like scary to read from a book, easy to use. So go over here. And this, what this means is the next number. This means the here, I'll do it from down here actually. The next number and this right here means the last number or the previous number. Okay, and if you notice, everything over here has to do with the previous number. Okay, so we guessed our number. We guessed one number. We guessed xn basically, which is 0.5. So we're going to say, what's the next number? So we're going to guess. We're going to try to. Even though we guessed x1, based off that x1, we're going to calculate x2. And what we're doing, which is kind of cool, is let's say our graph is like this. Okay, and let's say it's got different zeros, but let's say that one of the zeros, let's say one of the zeros is like let's say it's, let me think about this for a sec. Let's say it's point 0.8. We're going to start off at 0.5, and it's going to give us a new number after we do all this business. That's going to be like 0.7. Then it's going to give us a new number that's going to be like 0.78. Then it's going to give us a new number that's going to be like 0.79. And then we're going to get a new number that's going to be like 0.799. And then when we plug this number back into the original one for x, we're going to find that x is going to approximately be 0. The whole function will be 0. We're going to drill down till we get to the root. We're going to do like these iterations. It's going to like narrow it down until we actually find that unknown 0.8. Okay, you're kind of getting it. And so yeah, so we're going to go ahead and we want to find the next number. So we're going to do x2. That's our next number. x2 is equal to our previous number, which we guessed. So what is that? 0.5. Okay, minus, okay, the derivative of, the OG, so like plug it in. So we're going to go minus, how should we do this? Bracket over, and then you have 3 cosine. Definitely did not do this big enough. 3 cosine 0.5, close, minus, and if you maybe highlight, let me take this highlighter off this 0.8 right here, and let me put the highlighter on this guy up here. Okay, so this, or we could do here, actually just do this. Let's do 2 steps then. Do f of x over f prime of x. Bam. And this is going to be, even though it's kind of weird to write it like that, x2 equals. Okay, because you know how I said we're gonna like guess these different like we don't know point 0.8. In fact, that is probably not even the answer. We're trying to find that number, right? So we're guessing that the first attempt, we're guessing that like it's 0.5. We know it's not 0.5, right? So let's say we're trying to get to our 0.8, right? What we're gonna do is we're gonna guess 0.5. And we're going to run 0.5 into Newton's equation, and he's going to be like, no, that's not it, but I'm going to get you closer. I'm going to get you to 0.6. Then we're going to run it again into his equation, and it's going to be like, that's not it, but I'm going to get closer. It's going to be 0.7. x1 is 0.5. It's right here. So this right here is previous number. This is our first previous number. And this is our first next number. We don't know our next number, but we know our previous number. We guessed it. Our previous number is our guess, which is 0.5. Which I'm kind of wondering. I do have a question about this, but we'll see how it goes. Okay, you ready? Okay, so now we're dropping. So do you see how we're going to drop 0.5 into here, into here? So it's all the same number. It's all the previous number. Okay? So we have equals 0.5. And if you think about it, what all this is some sort of number divided by some sort of number. It's probably some sort of decimal. It's an increment. It's an increment away from 0.5. Like this isn't going to be like 10,000. It's going to be some small decimal number. In fact, it's not even going to be beyond it's going to be somewhere between 0 and 1. Okay, so you drop this into your OG. You drop the 0.5 into your OG. So you're going to have minus, your OG is up here in yellow, and that's going to be, I kind of don't want to put that in yellow down there. Okay. Okay. Sure. Okay, so I'll keep talking. So we're going to plug in 0.5 into the original equation. So f of 0.5, which is 3 cosine 0.5 minus 0.5 minus 1 over negative 3 sine 0.5 minus 1. So down here, we plugged it into the derivative one. Up above, we plugged it into the original one. Okay. Here we go. Are you there? Okay, so we're going to pull up our calculators. Do you have your graphing calculator with you? That's fine. I'll pause. Okay, so on our calculators, we want to be very careful how we manage our equations. So we know that this equation right here is, go ahead and type it in. The yellow one is our original. So just go ahead and type in 3 cosine x, make sure you're in radians. This entire class is radians. So cosine x minus 1. 3 cosine x minus 1. Bam. Who cares what the answer for now? Now put in your derivative one. So negative 3 sine x minus 1. You got that? Okay. Actually, there's actually, hmm, that's okay. Hmm. Hold on a second. So we have in the calculator the derivative one punched out for some value of x that we don't even know what that is yet. And then we have the other one, the derivative. We have the OG on the top and the derivative on the bottom, right? Okay, so now we're going to set our x equal to 0.5 because that's what we're plugging in right here, right? 0.5. Okay, so we're going to have 0.5. Oh, I know the smart way of doing this. Okay, so oh yeah, it's worth doing this. So you want to do is go parentheses, bring this down like that. Okay, so that's the entire top, right? Divided by, okay, parentheses, bring this down. That's the entire bottom. So now we actually have this setup right here. We have the top divided by the bottom, right? All in one like expression. All right, so I'm going to put that down right now. And now we're going to get our 0.5. 0.5 store as x. Bam. Now we're going to plug in 0.5 into the top and bottom at the same time. In fact, I'm not going to do it like that. I'm going to do it like this. I'm going to go right here. Here's my 0.5 in the problem. Oh, this is way better than I did before. This is, so you have your 0.5 in the problem. Then you're going to go 0.5, because we set our x equal to 0.5, but we still need 0.5. 0.5 minus, okay, bring that expression down now. There. Okay. So your calculator is going to follow orders of operations, right? And it's going to do all of this business first before it does that, right? Plug that in. Bam. 0.96. Okay. So now we found that x2 equals 0.96. Well, x3 equals point 0.96, the previous guy, minus bracket 3 cosine the previous guy, minus point the previous guy, minus 1 over 3 sine the previous guy. Oh, negative 3. Okay. And now we have our calculator, and we're going to go 0.96. Well, we're going to set our x equal to 0.96, right? So, in fact, I mean, we technically could like, let's put more numbers in there actually. 0.9, 0.96 0.9646. 0.9646. We'll do approx. All right. Okay, so then we do that, and since we have a calculator, we'll store that as our x. Okay? Ooh, I know how to make this even better. Okay, so then we have this. Why don't we just replace all of that? Why does that have to be 0.5? Why can't that just be x? Right? If we use this expression, we don't even have to plug in anymore. So you're, bam, 0.89. Okay. 0.89. that's our next, so x3, right, that was our x3, right, 0.89. So x4 is equal to 0.89 minus, bam. That's a wonderful question. Hold on a sec. Pause. So yeah, so store that answer as x. Well, we actually have to show work though. Hold on. So we have over here 3 cosine 0.89 minus 0.89 minus 1 over negative 3 sine 0.89 minus 1 equals, all right, now that we have that, we go ahead and bring down this awesome expression. Well, that's interesting. 0.889, right? 0.8894. Or just write that whole. I'm gonna write that whole number down. 0.8894, and just for the heck of it, let's do one more because it's easy. 0.8894. Okay, so then we go x5 is equals 0.8894. Oops. 94 minus 3 cosine 0.8894 minus 0.8894 minus 1 over negative 3 sine 0.8894 minus 1. Okay, on the calculator it's already set up for us to do that. You go over here, store x, plug it in. Look at that. Yeah, that's that's pretty darn accurate. So that's so that's still 0.8894, right? So now you check 0.8894. So 0.889. That's kind of cool how that works out like that. Okay, so then you go over here, and I think it would have still worked out, by the way, if I remember correctly. Um, if you know how we found it between like 0 and 1, um, I think you just have more steps if you want to do it between 0 like and 3. But then if you have more roots within there, then that complicates things because you don't even know which one, if you're finding the right root anymore. So you always want to try to get it to two integers that are as close as possible together. Okay. Okay. So what do? We get our original one right here, our OG equation, and we plug it in. You can even say that f of x. Let's figure out f of. Let's figure out f of 0.8894. 0.8894, and hopefully it is a number that's crazy close to 0. F of 0.8894 equals, would have been easier if I just wrote it all down, 0.8894, 0.8894, and then this is 0.8894. Are you punching it out? 3 cosine 0.8894 minus 0.8894 minus 1 equals 0. Okay, so we plug this thing in. And technically, I mean, we kind of already have the original somewhere. If we're really lazy. Yeah, it's like, it's like right there, right? That's the one. 3 cosine x minus 1. Bring it down. But I never actually, and then we'll just do this actual number with 4 decimal places, but 0.8894 4. Enter, store, x, and then bring down this one. Plug it in. Look at this. 2.3 times 10 to the negative 4. Okay, so what'd you get? You have that? Okay, good. That's good. So f of that, f of 0.8894 is equal to, let me just take a picture of that. Okay. Is equal to 2.334 times 10 to the negative 4, which is the same thing as 0.00012, like 2, 3, 3, 4, right? So 1, 2, 3, 4, right? 1, 2, 3, 4 puts us there. Yeah. So that would be that, which is crazy close to 0, right? So that's basically 0. In fact, I rounded my number. I didn't even put the actual number in there, so it would have probably been even closer to 0, right? So what are they asking us to do? Let's go back up. They're asking us to find all the solutions. Okay, hold on. So we found one of the solutions. Oh, and one sec. Pause. So we're going to plug straight into Desmos to actually see how many zeros we actually have. And we actually can see it from right here. We have that one, and that one. All right, so if you look here on Desmos, these are all of the solutions. But you notice that the one that we found, ta-da, we got positive. Oh, notice that we found one of the zeros right there, right? So what I would do, which we're not going to do it because he didn't assign this problem, but what I would do is, now that I know that, gosh, the next lucky number I'd like to pick would be like, if I know that I have a 0, if we know that here, we know that our zeros are like this now. We know the actual zeros, so we have negative 3.638. We know that's one. And we know another one. We know another one is negative 1.862. That's another one. And we know the other one is 0.889. Right there, right? So now the first time we did this, we picked numbers between we picked numbers between 1 and, what do we do? 0 and 1, right? So we picked numbers between 0. No, we did 3.14, but then first we did this. We found, we got 0. Maybe that was the first one we did. And then we did 3.14, and we said, well, yeah, that works, but let's try another one. And then I think we tried 2. And then we're like, yeah, that works. Well, let's try another one. And then we tried 1, and we're like, okay, cool. So we got it between 0 and 1. And then we did our iterations to drill down to this number here. You see? Okay. So what I would do, again, if you were given this problem, is I think a smart number to try would be negative 2. That would be my smart number to try, right? We're going to say, we would try negative 2 and negative 1. So we would do our negative 2 numbers. We would do negative 2, and our iterations will take us down to this number here. Then we would do our negative 4, right? And you would find, I guess you would find a number between negative 2 and negative 1, technically, right? So negative 1.5. That's the number that I would try. Negative 1.5. And then you do your iterations, and it'll drill you down to this number. What's that? Well, yeah, but I forgot. Remember, you find a number between the two. That's how we got our 0.5 to begin with. So here you have negative 4 and negative 3. So what number are we going to try for what number would you try for your x1? Yeah, negative 3.5. Okay, and so those, um, you would get your zeros like that. What's that? Yeah, if we just repeated the same process we just did, you're gonna get this number, and you're also gonna get this number. That's it. That's Newton's method. So, and there's other things you can do. I think like figure out like square roots and stuff that you might not know, but I don't think we have to worry about that. I think all you need to know is how to use Newton's method. No, because I have no idea how to do that. So I would have to A, look at the solution book, or B, listen to his video. But being that when I saw the videos yesterday, I was like, there's no way in hell I would have gotten that right on my own. So I would wait for his video. It's not a lot of, look, if you look over here, it's not a lot of problems. So, but if you look on your book, look at page, I'm going to turn off the video right now. If you look at page, stop and save.